A compound DC generator combines the features of shunt and series generators, having both shunt and series field windings. The shunt winding is connected parallel to the armature, providing a relatively constant magnetic field, while the series winding is connected in series with the load, strengthening the magnetic field as the load current increases. When the armature rotates in the magnetic field, an electromotive force, EMF, is induced according to Faraday's law of electromagnetic induction. The induced EMF is initially alternating, but the commutator converts it into direct current, DC. The series winding ensures that as the load increases, the flux also increases, compensating for voltage drops due to armature resistance, while the shunt winding maintains voltage stability under normal operating conditions. The brushes collect the current from the commutator and supply it to the external circuit, delivering a relatively steady DC voltage, which is higher than that of a simple shunt generator under heavy load. Compound generators are widely used in applications where both constant voltage and high starting torque are required.